This question looks somewhat challenging to begin with. If you're, maybe trying some values out, maybe, I don't know, maybe adults of £10, and then you could work out what the children would be over here, and you could see if it works over here. But that trial and error method is a bit limited, and we want a better method. So how about we try and form some equations? Let's call the price of an adult ticket A, and the price of a child ticket C. So then suddenly we can form an equation from here, this left-hand one, as 4A, 5 adult tickets, the cost of 5 adult tickets, plus the cost of 4 child tickets. That's going to equal 78. And then I can do the same with the second one. It's going to be 3A plus 6C equals 63. And suddenly I've created simultaneous equations. How do we deal with these? Well, there's numerous different ways. I'm going to do it by elimination, making a set of coefficients the same, the numbers in front the same. And I think I'll do it for these ones here. Doesn't really matter whether you make the coefficients of A the same or the coefficients of C the same. So what can I do? I could multiply them together. So I multiply the top equation by 6 and the bottom equation by 4 to make them both 24. Actually, a sneakier way is to find the lowest common multiple, and that's 12 in fact. So I can times all of this equation by 3 and all of this equation by 2. That's going to give me 15A plus 12C equals 78 times 3. I'm just going to get my calculator to help me with that. 234. And then the second equation is going to be 6A plus 12C equals 126. And what I can now do, now that I've got these the same, is I can subtract the left-hand side and subtract the right-hand side, because then these are going to go. 12C minus 12C cancels out, and I'm left with 9A equals, again, I might just get my calculator to speed the process up. 234 minus 126 is 108. And then actually that's going to give me A is equal to, I can do 108 divided by 9. A is going to be 12. Adult price is £12. Okay, bit more than the 10 that I estimated, and maybe maybe you could have done it that way. Maybe you would have tried 10, then 11, then you would have hit on 12. But what if it was £12.50 or something? This method is much more robust. Okay, we're not quite finished. We now need to substitute it back in, and you can actually substitute it back into any of these equations. I'm going to go with this one here because it looks sort of the simplest. If I had time, I might substitute it into the top one as well, just to check that it works. So when I sub back in, I'm going to sub my A equals 12 in, and I'm going to get 3 times 12, which is 36, plus 6C equals 63. And then I'm going to solve that. So 6C is going to be 63 minus 36, 27. And I think I am actually going to get a decimal answer for the children's tickets. 9/2 or £4.50. Okay, and that's it. I think I just want to show you. So I could check by just putting it into the top one. 5 times 12 plus 4 times £4.50. Let's check that gives 78. It does, so I can be pretty confident that I'm correct there.